Our next lesson is 10.4 Inscribed Angles. We are going to jump around here a bit. So we're going to start about talking about what an inscribed angle is. So an inscribed angle is an angle whose vertex is on the circle, right? And the sides contain chords, right? They could also be secants, but as long as they start and end on the circle, they're considered chords. So here at vertex R, we do have inscribed angle SRQ. Right? That's different from when we had our central angles, right? Central angles went from the center, inscribed angles go from the edge. The intercepted arc is now the arc that is basically what's being opened up by this angle. A lot of times I describe it as if we held a flashlight here at the angle, this is where all the light would be, right? So this arc is where the light would be. So arc QS is our intercepted arc, angle QRS is our inscribed angle. What's special here is that if I have an angle inscribed in a circle, then the measure of the intercepted arc is double the measure of the angle. So it doesn't matter what it is. Let's say we make up a number here that this was 50 degrees. If this is 50, this automatically makes this double that, or 100 degrees. Right? If we recall from our last lesson, central angles were equal. So if I had my central angle here, this would have been 100 degrees. But when I pull it back, when I make the angle smaller, it actually gets cut in half. So this is our formula for any time we have an angle on the circle. It's going to be arc equals 2 times the angle. This picture shows the same thing, right? In this case, it's not an inscribed angle, but the angle that we're creating is still located on the circle. Right? It's created by a secant and a tangent, or it could have been a tangent and a chord. But each of these angles then would be half of their arc, or the arc would be double the angle. So again, this is still on. I'm still using arc equals 2 times the angle. In our first example, we're going to find two things. We're going to first find the measure of angle x. So I'm going to look at my picture and I see that I have an x here. Right? That's where angle x is. And if I were to draw the two sides of angle x, all right, pretend I'm holding my flashlight here, it's going to be shining a light up here to the 86-degree arc. So if I use my formula, arc equals 2 times angle, and I substitute in my arc is 86 equals 2 times my angle, if I want to find out what my angle is, I'll divide both sides by 2. So that means the measure of angle x is 86 divided by 2, or 43 degrees. If I'm looking for arc yx, that's really the arc right here, right? I'd have to look, where would my flashlight be to show me this light? So if I pull back the two sides that made this arc here, I see I have a 52-degree angle. So again, if I set up arc equals 2 times angle, this time I don't know the arc, call it a variable if we want, equals 2 times my 52 degrees. Sorry about that. 2 times 52 degrees, now this arc would be 104 degrees. All right, so you go ahead, try these two, and when you're ready, unpause and check your answer. All right, if you're done, P is 35 degrees, and arc PO is 112 degrees. Moving on. In our next problems, we're going to find each measure. So we notice that we do have the angle on the circle in both of these, right? Angles on. In the first one, we're looking for the measure of angle QPR. QPR is this angle right in here. So I can put a little variable there if I want, make it easier to solve. So setting up arc equals 2 times angle, We do know the arc for that angle is 148 degrees, right? If we look here, this angle matches with this arc. So 148 equals 2 times the little variable we made up. And if we divide both sides by 2, we get that angle. I'll actually write it out, measure of angle, QPR, is 74 degrees. In part B, we're actually looking for the arc. And we're not just looking for the arc in here, right? This is arc DF. And that would go with this 64-degree angle. What we're trying to find is arc DEF, this whole outside one. So we're going to do this in 2 steps. We're going to find this arc first, right? If I do arc equals 2 times the angle, this arc is going to be 2 times the 64, or 128 degrees. This circle is only made up of these 2 arcs, which means together they have to equal 360. So I'm actually going to do 360 minus the 128, right? Because I want this part. We already know this part's 128. So that leaves me with arc DEF equaling 232 degrees, right? Notice here, it's the measure of the arc as opposed to the length, right? Arc length is something totally different when we're talking about inches or centimeters. This, as soon as we see the M, it means in degrees. So go ahead and pause, give these 2 a try, and when you're ready, check your answers. All right, for A, we should have 125 degrees. And B's question is actually slightly misleading. I do not like the fact that it is BCD. This should really be arc BD, because our answer ends up being less than 180, so it is in fact a minor arc, right? BD is over here, right? This would have been our major arc, this is our minor arc, and our answer actually comes out to be 144 degrees. Okay? So looking at our next thing, if I do have 2 different inscribed angles, but they share the same arc, right? So see how angle C here opens up to arc AD, and angle B here opens up to arc AD. That makes these 2 angles congruent, right? Because if I knew the arc was the same amount, if I were doing arc equals 2 times angle, I would cut it in half to find that angle, and I would also cut it in half to find that angle. So that's how we know they're the same. So in this example, we want to find the measure of angle T. We see angle T is here. It opens up to arc SV. Angle U is also going to be the same because it also opens up to arc SV, making 3x minus 5 equal to 2x plus 15. So we'll start by setting up that equation. Minus 5 equals 2x plus 15. We can solve this, subtract the 2x, add the 5. All right, we get x is 20, which is great, but that's not what we want. Remember, we're going back and finding the measure of angle T. So I'm going to plug it back in here. So we have 3 times 20 minus 5. So it's 60 minus 5, or 55. So the measure of angle T is 55 degrees. All right. So you're going to try that next one. Pause when you're good. Check it. All right, if you did it correctly, you should have gotten x was 5, and then the measure of angle R was 47 degrees. All right, almost done. The last 2 things are going to be about if a whole figure is inscribed in a circle. So specifically, if we have a triangle that's inscribed in a circle, and one of its sides happens to be the diameter, right? Goes through the center and points on the circle. That makes it a diameter. If that happens, then we can kind of look at it as, okay, well now this is a semicircle, so this is 180 degrees. And if I were to pull back and look at this inscribed angle, half of 180 is 90. So that makes it a right triangle. So anytime I have a triangle inscribed in a circle with one side being the diameter, it makes it a right triangle. That means this angle is equal to 90, and then these two added together equal 90. Also, if I have a quadrilateral inscribed in a circle, then its opposite angles are supplementary. So that means angle L and angle N are going to add to 180. They are not equal, they are supplementary. And angle K and angle M will be equal to 180. Okay? So we're going to try that. In example 4, part A, we're looking for the measure of angle F. I see that side FH is a diameter, making this a right triangle. So the remaining two angles have to add to 90. So we're going to do 4x plus 2 plus 9x minus 3 equals 90. So that's 13x minus 1 is equal to 90, which means 13x equals 91. And I get x is 7. I'm not done there because I wanted the measure of angle F. So I'm going to take this 4x plus 2 and I'm going to plug 7 in. So 4 times 7 plus 2 gives me a value of 28 plus 2, or 30 degrees. So the measure of angle F is 30 degrees. In part B, I want to find the measure of angle X and the measure of angle Y. So if I look at angle X here, and it's opposite this 60 degrees, and we said opposite angles are going to end up being supplementary. So I'm going to do 180 minus 60, and the measure of angle X would be 120 degrees. And then if I look at angle Y, it's opposite the 95. So for the measure of angle Y, I'm going to do 180 minus 95, and I get 85 degrees. So for the last two problems, pause, and when you're ready, check your answers. All right, so if we did this correctly, X would be 10, and I would have a measure of 76 degrees. For this, angle S would be 90 degrees. And for T, we would have gotten X equals 8. And then the measure of angle T would have been 68 degrees. And that is section 10.4.